Okay, so this is number 43 from the homework from section 6.1. So we're going to talk about vectors, but right now we're going to think of velocity vectors. So we're going to mix this this whole idea with an airplane and bearing. So what I want you to think about is if you have a plane, and the plane is flying at a bearing of 340 degrees. If I change that to an angle in standard position, that would be 110. And now we have a wind. The wind is blowing with a bearing of 320 degrees. So if I think about that as an angle in standard position, I end up with 130 degree angle. So they told us the velocity. The plane is 325 miles per hour, and the wind is 40 miles per hour. So again, we're combining forces now because we want to figure out what's actually happening. So if I had to guess, I'm guessing that the plane is heading in this direction. But I bet it's going a little faster because the wind is at its tail. At the tailwind, it's going to be pushing the plane a little bit faster. So we need to combine the component form for the velocity vector of that plane and the velocity vector of the wind. So over here for the plane, you have 325 cos 110 and 325 sine 110. For the wind, you have 40 cos 130 and 40 sine 130. So what we're going to do is we're going to combine forces, and we're going to add the x components of the plane and the wind velocity vectors, and the y components. Okay, so if I type this into my calculator, I should get negative 136.87, comma 336.04. Okay, so that's consistent with what we expected for the direction of the plane. So we want to find out how fast the plane is actually going. So we're going to find the magnitude of that velocity vector. So if you type this into your calculator, you should get 362.84 miles per hour. So we were right. The plane is actually going faster than 325. And you need to find this angle. So if you type this into your calculator, so inverse tangent of 336.04 divided by negative 136.87, and you end up with negative 67.84. So your calculator thinks you're in the fourth quadrant. So that reference angle is 67.84 degrees. So in standard position, that angle would be 112.16, which that would be fine to describe your angle in standard position. Or if you wanted to describe it as a bearing, you would do 270 plus the 67.84 degree reference angle. And you would end up with 337.84 degrees for your bearing. And again, that was 270 plus 67.84. There you go.